I'm learning a ton in this after show. So here's a question that came in all the way at the beginning of the pre-show. This question is from Redefine Living. And he says, question for the panel. Does the perfect assembly of these molecules grant the life element?
Well, take a simple, and I say simple sort of facetiously, bacterium, like a single cell, and let's say it died 5 seconds ago. It's got all of the parts for life, the nucleic acids, the proteins, lipids, everything you need, sugars, but it's not alive. And why is that? I mean, one of the problems is you need to have these gradients, these proton, chemical electrical gradients, where you have a concentration, a buildup of more of something, whether it's ions or salts or on one side of a membrane than another. It could be even just simple protons, like how the proton motive force works in the electron transport chain, and that's crucial to life. You have to be able to kickstart that somehow, and in order to have the energy to do that, you've got to have external sources of energy that you can harness. And there's a gigantic problem between raw energy and utilizing energy. How do you capture that? It requires some incredible, not just one protein or an assembly of proteins, but whole systems working together to be able to harness the raw energy of, say, sunlight. And so, it's not like you can just hope that lightning's going to zap the pond and then poof, the ions are going to shift across a membrane. I mean, first of all, is this membrane impervious to the ions or the protons? Because if it is, you're not going to get anything transporting across anyway. And if it is open enough to allow these things through, you're not going to keep your gradient for very long in some kind of electric jolt because they're just going to slip back inside. And the way modern cells do it is they have special protein channels that very carefully regulate what can go through and what is not allowed to go through. So if that's what he means by the spark of life, if he wants to say the first life it was a living soul or something, I think that's a theological or philosophical question. But from a biochemical standpoint, I'd say no. Even if you have all the parts, there's a lot more to it than just having the requisite parts involved.
Well, beyond just the requisite parts. For example, when I teach biochemistry, I make my students memorize a variety of pathways, glycolysis and the citric acid cycle. And they're going, I'm never going to use this again. And I go, you're probably right, you're not. But when we get to that section of the book, I want to be able to talk to you about how that's regulated. And I don't want to have to go through the mechanics of the chemical reactions that make it. Because life is not simply the biochemistry of the individual reactions. It's the regulation that operates those. It's the regulation that operates that regulation. It's regulation that operates that regulation. There are layer upon regulations that intertwine and interregulated. And when you pop the cell open, when you break that cell, when you destroy the integrity of that cell body, instantly you begin to break down that cascade of regulation upon regulation upon regulation, and the cell can't survive, can't go back, and loses that thing called life. So there was something that set up that initial condition of regulation upon regulation upon regulation, and that's one of the things. We can't call that the breath of life, but there's something mysterious about that level of and complexity of regulation, of interrelations of the regulation that occurs within a cell.
Very detailed answers. I appreciate that.
There are a lot of scientists who are beginning to wonder, as I have been for quite some time, about reaching the end of naturalistic biology and maybe having to look for other things. And they're not all theists. And for example, one of the things that I've been very interested in is the issue of teleology in biology, the issue of purpose. And of all people, Dennis Noble, who is not a theist. He is a very famous Christian physiologist. I'm sorry, famous British physiologist. He's not a Christian. Has been talking about teleological mechanisms in biology, including, for example, the immune system, which I'm not going to go into. It's very complicated. So I think that this idea that, which we're really talking about, when we talk about how hard it is to start life, what are we really saying? We're really saying that we don't have the tools. We cannot just use the current biological, biochemical tools of science to understand this problem. I think many of us would agree with that. We can't say that in a peer-reviewed publication because it won't get published. But I think we're getting to that point where it's not just, Christians, it's not just people of faith who are talking about the necessity to bring in other stuff, including theology. It's mainstream science is saying, we're not getting anywhere. I mean, the story of Sutherland with his very low progress. There's no other field in science that has such low progress as this. Think about it, right? Tell me another field that has gone nowhere in 70 years. And, James Tour keeps saying this, and he's right. There's got to be a reason for that, folks. What is the reason? Because
I was going to say meteorology, but they're doing some good stuff in meteorology. My weather app is not very predictive, but no. But I agree with you, Sai. Abiogenesis is making it feels like very little progress.
This is one thing we really want to emphasize with this research is we're not saying that, it's too hard, life is too complex, therefore God and that God of the gap. What we're saying is based on everything we know about the laws of chemistry and physics and probability that the trajectory of where we're going, it looks so much in favor from this scientific evidence that there's major prohibitions towards getting even close to the first life form, that the logical deduction is, you really have a dichotomy here. Either life originated by some intelligent input or it didn't. It was all completely natural. And as chemists and biochemists and engineers and geologists, we're saying, and all the other people working in these fields are discovering that it's the more we learn about how complex cells are and the number of obstacles chemically to even getting close to that is leading us to conclude that, hey, you can either hold out for some near impossible odds, or that someday in the future, probably hundreds of years from now, we'll make a little bit more progress towards the origin of life and still find out more about how more complex life is than we even know today. That's really a faith stance there. You're not basing your decision on empirical evidence. Right now, the empirical evidence is telling us that the only option here is that it took intelligent input to get to have life.
Yeah, I would add that it's not an argument from ignorance. Rather, it's an argument from a great deal of knowledge.
Yep.
Right. I mean, this argument has come only because of the knowledge increasing in our current scientific world. It didn't exist in the time of Darwin, this particular intelligent design argument. Only with more knowledge has it come to the fore.
Yeah, we, as scientists, as chemists, we're able to make chemicals and chemical systems, not anywhere near the complexity of life, but we can make some pretty complex things. When the energetics and entropy and all of the concentrations, the reaction rates, when they're all unfavorable, intelligence is able to find a way to create things. So we're basing that off of experience that multiple complicated systems can come together when intelligence or, a chemist or, a biochemist, someone puts them together. So we have examples of complex systems coming together with intelligence. So we're saying, yeah, like just reiterating what everyone's saying, it's not out of ignorance. It's just there's nothing positive, nothing that's coming out of the scientific field that seems to say these things are all going to snap together. And so you're going to believe in a myth, or you got to deny the science that's out there and hope for evolution of the gaps to come in and or something that we don't know about.
It has all the hallmark. Life has all the hallmarks of being engineered too, just like we expect. I mean, when I'm studying some of these pathways and just looking at this, the organization of life, I say, well, my computer, has data on the hard drive. If it crashes, if there's a problem, there's an error in the code, I could lose some really hard work on my computer. So I have a backup of it, to at least more than one location. Our cells are like that too. It's like we have not just one strand, but two strands of DNA, so that if there's a problem on this side, the enzymes can go along and say, oh, we got a problem here. What do we replace it with? Let's look over here. Oh, okay, A binds a T, G binds a C. We know what to put here. And so there's a redundancy there. And then we even have two sets of chromosomes for mom and dad. It is like, okay, maybe mom had a bad allele here, and so we'll kind of downregulate the expression of the genes in this area and upregulate the ones from dad, and there's redundancy there. And then you have all sorts of error check mechanisms and repair mechanisms and the biochemical pathways. It's like, all right, if we don't want to overproduce something, we need to shut off an enzyme. And there's like 6 or 7 enzymes that lead to this product. Which one do we shut off? The one in the middle, the one over here? From an engineering standpoint, you want to shut off the one at the beginning. Why do you end up with all these intermediates building up in concentrations, causing problems or using resources? And sure enough, the enzyme at the beginning of the pathway is the one that has the extra site on it, where it's allosterically regulated and slows things down, and it's all feedback inhibited. So the higher the concentration of products, it goes back and inhibits the starting enzyme, and that's how you would do it in an assembly line. That's how an engineer would think to create things, by controlling the regulatory points in the most efficient way possible. And you see that efficiency and that regulation all throughout the cell.
Right.
Well said, gentlemen. Again, I want to thank everybody on the panel for giving us their time for this incredibly important show and topic. This has been an epic night of shows, the pre-show, the premiere, and this very informative after show. Anyways, I'm going to hand it over to Rob. Rob, it is a privilege to everybody. It is a privilege and an honor to be hosting this epic event, an incredibly important event. So, Rob, thank you, and I'll hand it over to you.
It's a privilege and honor to be here also. Thank you, and to be a part of this esteemed group. We're very excited tonight for the release of this video. I'd like to emphasize that we're here tonight to discuss a video that happens to be distributed by Discovery Institute, and it's going to be on their YouTube channel. But that video, the Discovery Institute and this particular discussion and Standing for Truth channel on YouTube are completely independent entities. There's no association between them. We're just here to discuss a video, and we're grateful to Standing for Truth for hosting us to have this discussion and talking about something I think is of great interest to a lot of people. So thank you.
Amen.
I've been here a few times before. I'm Rob Stadler, and I'm a scientist in the medical device industry. I got my PhD from it's a Harvard and MIT Division of Health Sciences and Technology, kind of a long-standing association between Harvard and MIT. And I've been working in the medical devices for about 25 years now, and I authored 2 books. The first one is called The Scientific Approach to Evolution, and that came out in 2016. And then just last year, I co-authored a book with Change Tan about the origin of life, which is the topic of this evening. And that book is called The Stairway to Life. And that's how I really got heavily engaged into abiogenesis And this is kind of moving on from there to continue the topic and continue understanding that. So I'll hand it over to Ryan.
Thanks, Rob. Yeah, it's good to be back here again. Yeah, just as a quick introduction, I have my PhD in chemistry from Northwestern University, and really have spent, I like to say 30 years just to try to beat Rob there in the science, but I would say about 20 years of professionally being a chemist, but 30 years of trying to practice chemistry and putting my hands on chemicals and trying to learn their behavior, how they react, learn how functional groups work. And I work here at Andrews University, and I've really gotten into this abiogenesis field here in the last last few years. Because as a chemist, that's where you would end up. This is where my expertise, and how molecules behave and react. I feel like I'm able to contribute and look and reason about the information that's coming out in the academic journals in this field. And so it's been a real interesting read. So it'll be great to talk about that. So I'm not sure what else to share, but we'll turn it over to James next.
Hello, good to see all my friends here that I meet with every week as we brainstorm on these ideas and turn them into animated videos that I hope you guys will enjoy. Something we try to target at the layperson level, but also have some sophistication in there, and we can gladly fill in the technical details in the after show on that. But I'm a biochemist. That's what my PhD is in. Same with Dr. Nowak at Andrews University. And I've been teaching at Loma Linda University, a sister university, for about 10 years. And I just love science. I think any scientist can agree, they just have this natural curiosity about the sciences. So I just love to dabble in so many different areas. I've taught 15 different science courses. And so because I love learning, and abiogenesis has been something that's been interesting, fascinating to me, because of the many challenges and solutions and lack of solutions that it affords. I'm a problem solver, and I like to pick apart these problems and find out what works and what doesn't. And so it's one of the reasons why I joined this group, to try to tackle such a challenging and important issue. So I'll pass it on over to Dave.
Yes, thank you, James. I appreciate it. Apparently, I'm the elder statesman here in this little group. I've been teaching at the college level for well over 30 years, and been a biochemist since 1988. I graduated from Purdue University in West Lafayette, Indiana, with a degree in nutritional biochemistry, and my work was with vitamin A. But fundamentally, I am a teacher. And as I have taught biochemistry and looked at a wide variety of biochemistry books and so on, the explanations that I read for how life became from no life clearly became completely inadequate. As I read it, I knew that just reading it. And over the years, that became more and more important to me. And then when Ryan joined Andrews University several years ago, we began to kind of talk about this, and we realized that we were very much on the same page about the mystery and the uniqueness of life, and how chemistry can inform it, and how to a greater or lesser extent. And so that's how I became a part of this august group, in being able to contribute my particular sense and understanding of biochemistry to how life began. And it's great to be here. I look forward to this next few minutes, and to the debut, and to the after show. Monty.
Hello, I'm Monty. I'm a geologist, so I'm the least chemist of the group, but I have taught chemistry. We do quite a bit of chemistry, and thing about geology and abiogenesis is that we're the ones that have to go actually look at the rocks and see if the conditions existed that could in any way make any of this possible. I used to teach, taught for many years, and now I am just doing research.
It's great to be here. Let me just say I'm really honored to be with you guys. It was a fantastic video, but we'll get to that in a minute. I have a PhD in biochemistry. I'm afraid that I am taking over from David the role of senior person here. I've been doing this for 35 years or more. So yeah, I'm old. I was raised an atheist, and I became a Christian in my middle years, and I guess that's about it. I've been recently working in abiogenesis in a number of interesting areas, including the origin of self-replication, and more recently, some looking at the origin of the genetic code. So I'm working in it. I think it's a fascinating area. I really like what Ryan said about it. I mean, it's a great field of chemistry, and my focus is really on what happens a little bit later, like when we actually start to think we have actual life. Mm-hmm. That's because I'm a biochemist and not just a chemist. But hopefully there will be later videos that will tackle that issue, and that'll be a lot of fun.